In this video, we'll have a look at the user experience in editing snapshots in the VEdition project. For this demo, we will be using a mock autograph of the first limerick in the Book of Nonsense by Edward Lear. The short text we want to represent is printed at the bottom of this excerpt from that book. Let's pretend that this is the facsimile of a sheet which froze in time the writer's creative process. This is our snapshot, a mix of text and annotations on top of it, hinting at its transformations. We will represent both the objective state of this written sheet of paper, together with its visual appearance, and the subjective interpretation which selects and orders the transformations we infer from annotations, generating many different versions of this text. As you can see, here some words have been replaced, a couple of verses have been inverted, and a word has been added. Let's now see how to use our editor. To focus on it, we will be using a demo UI, which starts with a preset snapshot. We will remove its sample data and start from scratch. Let us start from our facsimile image. We'll show it behind our snapshot. So we reset the current metadata and load a new one. This appears on the right. Then we insert our base text. This is just plain text. Once entered, it gets dissected into characters, each with a numeric ID. These are the nodes of our graph-based model. Operations will just define different ways of linking them, optionally adding new ones. The text appears on top of our image. We can better fit it by just changing a few parameters, like start offset, line height, and text style, as defined by cascading style sheet statements. This allows for various degrees of approximation in our surrogate text representing the snapshot. To make the text more readable, we make the background image less opaque. This way, our base text looks better on top of our facsimile. That's our base text, the first stage in its transformations. We now need to represent these transformations with editing operations. In our subjective reconstruction, the first operation is the replacement of word cried with said. This word ranges from 40 to 44. As we can see, it spans 5 characters starting with the one with ID equal to 40. On the visual side, looking at rulers, we could place this word at about 150 for X and 80 for Y. This will better fit the original image. So, we're now going to add this replacement. We add a new operation. First, its type is replace. There are many more to pick from. Replace is the default. Our coordinates were already filled in from our selection. Start with 40 and span for 5. We then enter the new value for the word, which is said. Let's add some features. We may want to add a log feature, just to keep track of transforms. This is global as it refers to the version as a whole. Next, we add an X feature for the new word's position. We saw that it was 150. This feature is unique in its set. Then, we do the same for Y, whose value was 80. A last feature can be the CSS style for the new word. Here we want a smaller, red text. Features will be projected from rule to text version or nodes. So, we have entered essential data for our operation, plus some metadata. There is much more we could do, but presently we're okay with this. We just save. This operation transforms the input text into another version, generating it. You can see it here, tagged as V1. We can see that said replaced cried. Each of its characters received metadata from the operation. The whole text, version v1, also got a log feature. Every single node, linked to build this new linear sequence, got its metadata. Also, look at the visuals. We have our new word, smaller, in red, located where we wanted. Hovering on each character shows its metadata. This is true for any visuals on this surface. Now, this is just our first operation. Our snapshot has much more transformations, as we can infer from its annotations. We could enter each one in our UI, just like we did for the first one. Yet, we also have a quicker way to enter essential data of operations. This is a domain-specific language designed for them. Using its syntax, we can describe operations and their metadata in a highly compact, plain text form. Here you can see a quick recap of this language, as displayed in the UI. We will thus leverage this alternative input method here. So, here you can see all the operations we want to represent for this snapshot, encoded with this language. Of course, the sequence of these operations depends on our subjective reconstruction, even if constrained within the objective hints provided by the snapshot annotations. The first operation, in gray, has already been entered using the UI. The second one is another replacement. The word swans is replaced by crows. From the snapshot we can see that, in turn, this will be replaced by yet another word, owls. But in our reconstruction this happened after other changes. Of course, a lot of factors might determine this reconstruction, even a material one, like a different ink. As you can see, the operation starts with the ID of the first node, 99, and the span of nodes to include from it, 5. This is the span corresponding to the word swans. This span is replaced by the new word, crows. As before, we add some features to the operation, a log entry, x and y coordinates, and a style. The other operations are similar. The next one is the insertion of have before the last verse. Note that here we also add a supposed reason for this, which is metrical. Features are an open set, so we can add any type and number of them. We also have a version feature, which marks the output of this operation as a staged version in the flow of our transformations. Each operation is a transformation, which generates a new version, a step in the path leading from the base to the final text, when there is one. Step after step, we move towards it. The path can also branch, but in this simple example we just have a straight one. Along this path, some of these steps may represent waypoints we want to mark with a flag. These are the staged versions, that for any reasons we consider as true, distinct and meaningful versions of the original text. So in this case, the output of this operation will be marked as a staged version named alpha. Again, we have a non-textual annotation, an arrow, implying a swap operation for two verses. Many of the operations have some visuals beyond their text, like the strokes on top of replaced text. Some have none, like for said, some have both, like for swans, with both a stroke and a new text on top of it. Some are purely graphical, like this arrow. Finally, the last operation is yet another replacement. The word owls replaces crows. All these operations and the metadata to project on output versions or on some of their nodes are summarized by this text. We just have to enter it. So, let's add a batch of operations. There will be 4 more of them, as we've already entered one by hand. As you can see, we now have 5 operations in our reconstruction. And if we look below, we can see that each of them generates a version of the text. The panel at the right allows us to browse through these versions, each being the output of an operation. From a few lines of plain text, we let the software generate all of them. Whenever we select a version, we see its text. Also, we can look at the visuals in the corresponding snapshot preview at the bottom. So, here we can follow our reconstruction step by step, along our path, from the base text to its final version. The text changes accordingly, together with the visuals, when they are present in the snapshot. Currently, the only visuals we defined are the new text introduced by replacements or insertions. We will add the rest soon. Meanwhile, consider that, in each version, metadata were projected from operations not only on versions, but also on specific nodes in them. For instance, here you can see the metadata attached to the word owls, character by character. Now, as we've seen, many operations correspond to visuals, like strokes or arrows. Yet, if we look at the snapshot view, such visuals are still missing. So, let's add them by editing each operation with a visual. The second operation corresponds to a stroke. We thus use SVG to represent it, in the diplomatic area of that operation. SVG can represent any geometries on our surface. Here we just have a segment. As you can see, we now get our stroke on swans. That's the replacement visual. Again, the insertion operation has a V-shaped sign above the text. So we add the corresponding SVG in its diplomatic data. The swap operation instead has a purely geometric visual. Here, a double-edged, curved arrow represents the inversion of two verses. Again, we add its SVG and see the result. Finally, the word crows replaced by owls has yet another stroke. Let's add it to the corresponding replacement operation and look at the end result. Now all the visuals are represented in the snapshot. This not only includes the text injected by operations, but also all the visuals used by the author to hint at them, even when they are not textual at all, like in the case of the arrow. We thus easily created a snapshot, with its distinct objective and subjective plans, and textual and visual layers, all integrated in a higher abstraction level data structure. We just scratched the surface here. For more information, please see this link. Thank you for watching.